Welcome to this video on the topic of advanced trigonometry. In this video, we'll be having a look at two pieces of mathematics. The first piece of mathematics we'll look at is the idea of having exact values coming out of the sine, cosine, and tangent functions. In the second part of the video, we'll have a look at why these exact values are the way they are. But first things first, let's have a look at this idea of exact values and these trig functions over here. So starting off, we have the sine function, so sine theta. What we're going to find when we go up by 0 degrees to 30 degrees to 45, 60, and then finally 90 degrees, we see that the sine function has some regular exact values that come out when we put them in a calculator. So bringing up the calculator, if I go sine of 0, probably guess that this one's always going to come out as 0. Sine of 30 is always going to come out as a half. Sine of 45 comes out as the square root of 2 over 2. The sine of 60 degrees comes out as the square root of 3 all over 2. And finally, the sine of 90 degrees is going to come out as 1. Now, the first two, sine of 0 and sine of 90, they're easily predicted by observing the unit circle. So what we observe is that on the unit circle, this green line over here is the sine theta. And what we find is that when we get a value of, or an angle of 0 degrees, the triangle itself is squashed all the way down the bottom. So it's not actually a triangle, it's just a straight line that touches the unit circle all the way on the x-axis here. So you're going to find that this green line here is a value of 0, as you'd expect. And similarly, when we get to a theta value of 90 degrees, that means that this blue line over here is pushed all the way up to the top of the unit circle here with a coordinate of 0, 1. In which case, the green line itself is equal to the hypotenuse of 1, which gives us a value of 1 like so. Now, the second one to look at is the sine of 45 degrees. We get the square root of 2 on 2. So it's somewhere in between there. So we can just throw that value in like so. And then finally, the other two values, sine of 30, we get a value of half, and a sine of 60, we get a value of root 3 on 2. Now, looking at this, what we find is that this pattern itself goes up in a regular and repeatable manner. We've got 0, a half, root 2 on 2, root 3 on 2, and 1. What we actually find is that if we do all the mathematics behind this, we can rewrite this as square root of 1 over 2, the square root of 0 over 2, and the square root of 4 over 2. So what you can see here is a pattern. The only things you need to remember are the 0, the 30, the 45, the 60, and the 90. Or you can think 0 plus 30, 30 plus 15, 45 plus 15, and then finally 60 plus 30. So the first increment is 30, 15, 15, 30. And then underneath that, you've got this pattern where it goes up by 0, root 0 on 2, root 1 on 2, root 2 on 2, root 3 on 2, and finally root 4 on 2, which can all be simplified down to 0, a half, and finally 1. Now, if the sine function behaves in this regular and repeatable manner, remembering that the cosine is related to the sine function in that it sort of does the opposite to whatever sine is doing. As sine increases, cosine decreases, and vice versa. We can expect to have exact values for the cosine function as well. And what we actually find is that the pattern we see in the sine function here is mirrored in the cosine function, but in reverse. So, having a look, we go cosine of 90, we get 0. Cosine of 60, we get a half. Cosine of 45, we get root 2 on 2. And finally, cosine of 30, we get root 3 on 2. And obviously, cosine of 0 is going to be 1. Now, for the first quadrant, this holds true. In the second, the third, and the fourth, the values are sort of similar with a few transformations applied to it. So we'll just change this to first. But before we get into that, what we'll do is we'll have a look at the tangent function as well. Now, in the past, I haven't really told you what the tangent function is. Rather, all I've said is that it's just a trig ratio that we use to work out the sides of a triangle. However, the tangent function is actually related to both the sine and the cosine functions together. What you find is that for tan theta, the ratio itself is the opposite over the adjacent. Now, interestingly enough, if you do a little bit of clever working out, perhaps you might have figured it out. It's actually the opposite over the hypotenuse multiplied, or I should say divided, by the adjacent over the hypotenuse. And what you end up finding is that these two over here cancel each other out, so it becomes the opposite over the adjacent. However, the opposite over the hypotenuse is equal to sine of theta, and similarly the adjacent over the hypotenuse is equal to the cosine of theta. So the tangent function itself is equal to the sine of theta divided by the cosine of theta. And having that information intact, what we can actually find is that now the tangent of 0 degrees, it's simply going to be sine over cosine, so it becomes 0 over 1. Tangent of 30 degrees is going to be a half divided by the square root of 3 over 2. Tangent of 45 degrees is going to be root 2 divided by 2 over root 2 divided by 2. Tangent of 60 degrees is going to be root 3 divided by 2 divided by a half. And then finally, tangent of 90 degrees is going to be 1 divided by 0, which looks a little bit strange at this point in time. Now, doing the simplification on all of these sums over here, what we find is that 0 divided by 1 is simply 0. Half divided by root 3 on 2 is going to be 1 over root 3. Root 2 over 2 divided by root 2 over 2, well, they're both the same, so it's nice and easy. It comes out to be 1. Root 3 divided by 2 divided by a half, that's going to be the square root of 3. And finally, 1 divided by 0, you put that in your calculator. It doesn't give you a meaningful result. So you actually get a value that is undefined. So you just call it undefined, like so. Or another way you can put it is, this one comes out to be positive infinity, but in maths terms, we just write it as undef. So this is the first quadrant of the unit circle. Now, we're not up to the second, third, and fourth quadrants, but we can just throw the values in for now, and in the next lesson it'll make sense why they are, or why they are the way they are. So the first quadrant is obviously this guy here. This is the second, this is the third, and this is the fourth. So filling in the sine function, what you find is that when sine is at 90 degrees, it's going to be at 1, and then it's going to start descending back to 0. What's going to happen is it follows the same pattern, so it goes 1 to 0, but it does it in reverse to what it did up here. So root 3 on 2 comes first, root 2 on 2, and then finally the square root of 1 over 2, which is just a half. And we can repeat that in the third and the fourth quadrants. So we go 0, 1, and it's sort of going to be ascending again, but there's a slight twist in it. Right, because in the third quadrant, what we end up doing is dipping below the x-axis, so we're actually in the negative values now. So this green line here is going to be represented down like that. So it's actually negative values of sine here. And as a result of that, rather than having positive exact values, we get negative exact values. So if we go ahead and have a look at that, we get sine of 210. Comes out to be a value of negative a half. Sine of let's say 240, negative root 3 on 2. So that's why they're negative over here. And then finally, we're going to be at negative 1, back to 0 over here. In between, we'll be at negative root 2 on 2. And then because we're going in between, we go negative root 3 on 2, negative root, don't need that, negative a half, like so. So this is all the exact values that we need to know for the sine function across the entire unit circle here. Now going for the cosine function, we follow the exact same pattern in that we're going to go 0 and 1 over here, because up top here the horizontal component is going to be at 0. So go 0 back to 1. In between there, we're going to get a root 2 over 2. We're going to get a half, and then we're going to get a root 3 on 2. So it's effectively just counting up and down. Alright, now that we've got the values inside the table, we have to look at where cosine is positive and where it's negative. What you're going to find looking at the unit circle over here, when the orange line here is across on the opposite side of the y-axis here, we're in the negative values of x. So you find that cosine is negative in the second and the third quadrant. Hence, for the second and third quadrant exact values, we also expect to see negative values showcased on this side as well. Verifying this on our calculators just to make sure we haven't made any mistakes, we go cosine of 120 degrees, we get negative a half. Cosine of 210 degrees, we also see a negative root 3 on 2. However, when we go cosine of, say, 315 degrees, we see that it's back to positive because it's in the fourth quadrant here, which is in the positive values of x as shown over here. So it becomes positive root 2 on 2. Now going for the tangent functions, once again, over here it's undefined. Then in the tangent of 120 degrees, because sine is positive and cosine is negative, we're going to see a negative 3, then we'll see a negative 1, then finally a negative 1 over square root of 3, followed by a 0. Putting the values across again, we're going to get a 0 over here, so 0 divided by negative 1 is 0. Sine and cosine are both negative for 210 degrees. Hence, we're going to see a positive 1 over root 3, followed by a positive 1, a positive root 3, and then followed by another undefined in the positive direction. Finishing off the values for tangent, we're going to go undefined once again, all the way back to 0. In between, it will be 1. However, it's going to be negative because sine is negative in this region, but cosine is positive. Filling in the rest of the values, we're going to get a negative root 3 here, followed up by a negative 1 over root 3. And thus, what we have done is we have completed the exact value table for the unit circle for increments of 30, 15, 15, and 30 degrees. Given the length of this video, what we'll do is we'll leave it here for now, and in the next video we'll have a look at where these exact values actually come from a geometric perspective.